Okay, I'm going to look here at proving that cos of A minus B is equal to cos A cos B plus sin A sin B, as is in the log tables. To do this, the important bit is the setup again. So the setup for this is going to be a unit circle of unit length 1 unit. And on that circle, we're going to have 2 points P and Q. And from there, we're going to have the angle out to P. If a straight line from P back to the origin has an angle of A, and the distance from Q back to the origin will have an angle of B. I'll just highlight those there. So that's my B and that's my A there. Okay, and we're going to try and find, well, we're working with this bit in here. Is that okay? And this is, well, just A minus B, if that makes sense. So the angle there is just A minus B, and that's where we're looking at that cos A minus B. So really, we're going to try and find the opposite side over here, the length of this opposite side over here as this proof. And the length of that opposite side, PQ, it can be gotten in two different ways. We can use the cosine rule, which we've already proved, so that means we can use it. And so that's one of the ones. And we can also use the length of a line, AB, in coordinate geometry, okay, and we're going to use that as well. So let's go about working with those two. So we have A squared, which is the side PQ squared, really. I'll leave it as A for the moment, is equal to B squared. So looking at this, the unit length is 1, so that means each radius is just 1. So it's just 1. That side is 1 squared plus 1 squared minus 2 times, again, 1 times 1 cos. And the angle that we're looking at here is A minus B. Okay, so tidy all this up. A squared is equal to 1 squared plus 1 squared is 2 minus 2. 2 times 1 is just 2 cos A minus B. Okay, and we can just leave it like that for the minute. So we're looking at that angle, this side over here. I'm going to call it A opposite the side. And again, it is that. I should really not have it as A because the angle A, it doesn't match up. So I'll just call it PQ. And again, I can change this here to PQ as well. Okay, so that's just using the cosine rule to try and tidy up the length of that side. And now using the length of a line formula, I've started off here as well. So let's just stay working through it. Again, let's change this to PQ now. Is equal to, well, I've already this populated here. So it's cos B minus sine A. So again, just looking up here, my x1 and y1 were cos A and cos A sine A, cos B and sine B. So let's expand out this. So it would have been, starting off, I should have had it as the square root here. So I'm assuming this is squared when I get rid of the square root sign. And it's going to be cos squared B minus 2 cos B cos A plus cos squared A. So that's just all the first bracket. So that turned into that in the expansion. Let's stay going with this. So I'm going to go down to the next line to expand the next one. So it's going to be sine squared B minus 2 sine B sine A plus sine squared A. Okay, let's just use, so that's all just that there in its expansion. Let's try and tidy this up. So there's a bit in this now. PQ to be squared is equal to cos B plus sine B. That's just 1. Oh, sorry, cos squared B plus sine squared B. Let's just write it all down for a second. I have cos squared A plus cos squared A plus sine squared A. Again, that should equal 1 in a second as well. It's not the first time we've used that one. And then we have minus 2 cos A cos B and minus 2 sine A sine B. Okay, just tidying up some bits here. I say everything, that bit there can turn to 1. That bit there can turn to 1 as well. So again, it's just the log tables, page 13 if you're not sure. Cos squared A plus sine squared A is equal to 1. Obviously, it doesn't matter what the angle is once it's the same angle. So it's 1 plus 1 is just 2 minus 2. Cos A cos B minus 2 sine A sine B. Okay, so now we have, that was the tricky bit, okay. Now we have this here as a p q to be squared is equal to that, and pq to be squared is equal to that. So why don't I let both of these things that pq squared is equal to one another. Minus 2 cos A minus B is equal to 2 minus 2 cos AB minus 2 sine A sine B. Sorry, there's a... that should be a cos B, shouldn't it? Okay. And let's try and formula manipulate this across. I want to be left with just cos A minus B at that side is equal to something. Okay, so I'm going to have minus 2 cos A minus B. Bring across the 2. It'll be minus 2 plus 2 that'll cancel out. I'm going to take minus 2 here and factorize it out of the other 2. So cos, I'm all Russian now and going nowhere, cos A cos B plus sine A sine B, and divide both sides by minus 2 to leave me with cos A minus B is equal to cos A cos B plus sine A sine B. Okay, that's one of the trickier ones if we're asked to do it, but if we are asked, we will do it, and we'll have it learned and we'll have it right.